Okay, so today we have the integral from 0 to pi of e to the cosine t multiplied by sine 2t with respect to t. Now the first thing you'd notice is that we have two problems in our integral. We have a double angle and we have e raised to a trig function. So we look pretty hopeless right now. So, noticing that we have a double angle, let's use the double angle identity for sine. So we have sine 2t is going to be equal to sine t cosine t. Okay. Let's put this in there. Let's see what happens. So we have from 0 to pi e to the cosine t. Then we said this part is 2 sine t cosine t. Aha! We have a cosine here and a cosine here. That kind of tells me that cosine is going to be my problem for today. Okay. And what I like to do with our problems, well, I say let k equal cosine t. Now, why am I using k? Because we still have to apply the integration by parts technique, and we have to use u. So it's gonna get less confusing if we use different variables. Now this implies that then dk is gonna be minus sine t dt. Now if I divide both sides by minus sine t, that's the same thing as multiplying by 1 over sine t. That is not dt, that is dk. And of course, don't forget that negative. Okay, now we are ready to make some changes. So this integral, gonna write it out once more. That's gonna be equal to that same integral. And then we have e to the k 2 sine t. Now we said cosine t is k, so we can k, and then dt is minus 1 over sine t dk. Now if we notice, these two will cancel, and of course we cannot forget about this negative. So I'm going to take this negative, I'm going to pair it with this constant of 2, and then I'm going to pull it to the front of our new integral. So this is going to be equal to minus 2, 0 to pi. This integral looks a bit weird. That looks better, but now the pi looks weird. There we go. So e to the k, our signs cancelled, so we just have k dk. Now we are ready for the big boys. We can apply integration by parts. So u and dv. How do we pick u? We want to reduce the power. So if we look, if I pick e to the k to be u, take du, this is going to stay the same. So I didn't reduce any power. But if I pick k, okay, I need to take this out. If I pick k to be our u, then du is going to be dk, and that means I reduced that power because the k is no longer there. Okay, and since we picked k as our u, then this and this is going to be dv. So e to the k dk, and then we take the integral to get v, so that v is still e to the k. Okay, simple enough. Now this is going to be equal to minus 2 into. Now we apply integration by parts for this part. So it says u times v, which is k e to the k minus the integral of v du. So e to the k dk. And then we evaluate that from 0 to pi. We evaluate the whole thing from 0 to pi. Okay. So minus 2 into. Now what I'm going to do, I'm going to take this integral and I'm going to sub in back k at the same time. So what is that going to look like? It's going to be cosine t e to the cosine t minus e to the cosine t, and from 0 to pi. Okay. Now all that's left to do is apply the FTC part 2 and just sub in our bounds. Okay, what is that going to look like? So minus 2 into. Now, before I do that, I think I want to factor out a e to the cosine t. I might be making a mistake here. Well, not really a mistake. I might be making this harder for myself, but I feel like if I do this, it's going to make it easier, but we shall see. So if I do that, then this disappears and then this becomes 1. Okay, we can clearly see that. Then we still evaluate this whole thing from 0 to pi. Okay. I think, yeah, this should be easier. Yeah, that looks better. So now we can sub in. So e to the cosine pi into cosine pi minus 1 minus e to the cosine 0 into cosine 0 minus 1, and then we have a bigger bracket there. Okay. Okay, cosine of pi. Now, just so that we don't get confused or not, this is just like a personal preference. I always like to draw my cosine or my sine graphs on the side, just so that I can visualize the values. So that looks so bad. Okay, I'm gonna try and put it. Okay, I'll keep it in the same place. Okay, that looks a bit better. So how does cosine go? So it goes from 1 to 0, then negative 1 to 0, and then keeps going like that. That is a very bad graph, but it's gonna get the job done. So at here is 0, at here is pi over 2, and at here is pi. So this is gonna be e to the minus 1 into cosine of pi, so that's minus 1 minus cosine of 0 e to the 1. Cosine of 0 is 1 minus 1, that's going to be 0. Going into that, and then we have minus 2 into e to the minus 1, that's 1 over e. That's going to be into negative 2 into, that's going to be minus 2 over e. Oops. And then finally, if we put that negative 2 in there, that's going to be 4 over e, and this is an area, so it's going to be units squared, and this is the final answer. And if you need the whole solution, this is the entire solution with my bad graph.